Hi, so I hope that you had a great break and that you're coming back ready to learn. We are starting in Module 6 with systems of equations. This is more than one equation. And the definition of systems of equations, let's start with that. This is two or more equations with the same variables. So for Algebra 1, we are just going to deal with the two, but it can be more than two. It can be two equations, three equations, four equations, and as we get more and more of these, you would have to solve these with matrices as you get into higher levels of math classes. But for now, we're just going to deal with two. The solution, or the answer to a system of equations, is going to be done two different ways. We're going to graph these things and find out the point where the two lines intersect. And sometimes it's not most beneficial to graph. Sometimes it's more beneficial to solve algebraically. We will also end up finding a point where the two lines intersect. So there's a few types of solutions. We have intersecting lines. So if we have a line that has maybe a positive slope and a line that maybe has a negative slope, they intersect at a point. That would be one solution. And that point, we know when we're dealing with points on the coordinate plane, there's an x value and a y value. When we have parallel lines, that means they have the exact same slope and they never touch. So there is a no solution. There's no way they touch, so they don't have a solution. These guys touch in one place, so they have one solution. If we graph a line, and then when we graph another line, it ends up mapping directly on top of this line, like this, then that would be infinite solutions because they touch in exactly the same spot for all eternity, both to the left and to the right. So today we're going to focus on solving systems by graphing. You have already been graphing a line, so we're going to continue with that knowledge. We have a couple steps. First step, we're going to make sure to rewrite, if we need to, the equation in slope-intercept form. The reason that's important is because it's a lot easier to graph when we can see the y-intercept and the slope. Step 2, we're going to graph the line. In step 3, we're going to identify the solution or solutions. All right, let's get this party started. I'm going to use two colors for graphing today so that it's easier for you to see the difference in lines. Thankfully, on the front page of these notes, notice that our first step, rewrite the equation in slope-intercept form. This is already in slope-intercept form. Don't forget, slope-intercept form is y equals mx plus b. So the y is alone and everything else is on the other side. The b is always our y-intercept and the m is always our slope. So I'm going to graph the first line in blue and then we'll graph the second line in green. All right, first line. The y-intercept is -8. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and put a dot. Then I'm going to follow the slope to the next point, and there is no number in front of x, so we know that number is a 1. So I'm going to rise 1, run 1. Rise 1, run 1. All day long. Go ahead and graph that. The second line I'm going to do in green. So let's find the y-intercept as a 1. And then we're going to go down 2 over 1, down 2 over 1. You can do this as long as you want to, because remember, part of being a line is having a constant rate of change. All right, so the place where these things meet, this is an example of intersecting lines, so it should have one solution. And our solution right here is the point 1, 2, 3 over, and then 1, 2, 3, 4, 5 down. We have done our first system of equations. Let's do number 2. First line I'm going to graph in dark blue. The y-intercept is always graphed first, the number 9. So I go up to 9. Keep your pencil there, and we're going to follow the slope. The slope says rise 1, run 2. Rise 1, run 2. We can back it up if we need to, so we can see a little bit more. Notice it's still rise 1, run 2, so you know you did your line correctly. Your green line, go up 6, 1, 2, 3, 4, 5, 6, put a dot. Has a negative slope, and there's a 1 there, so down 1 over 1, down 1 over 1, all day long. This is another example of intersecting lines. So this is our solution. Let's figure out what point that is. Remember, x comes first, then y. So to get to this point, we go left 2, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. We have our second system of equations solution. Okay, turn the page over. Okay, I want to do a couple of these that are going to be a little different. So I'm going to do number 4. I'm going to do 5 and 6. And then I'm going to do number 7. Okay, so number 4, here we go. Step 1 on the other page said that we needed to have these in slope-intercept form. The second equation is ready to be graphed. The first equation is not in slope-intercept form. That's in standard form. So let's move some things around. We need to first, let's move the x to the other side, just like last semester. And then everything needs to be divided by 2 so that we have it in slope-intercept form. All right, well, do you notice something about these two equations? Yes, Miss Boykin, they are the same. Yes, they are. So if we graph both of these lines, y-intercept of 2, then down 1 over 2, down 1 over 2 all day long. So I just graphed one of these lines. Now I'm going to graph this line. Oh, wait. Y-intercept of 2, down 1 over 2. So if I graph the green line on top of the blue line, we notice they are the same line. So they touch in every single spot all the way down the line. So how many solutions do we have? Infinite solutions. They are the same line. Same line. Infinite solutions. All right. Let's do number 5. Well, this guy says y equals. We know we're going to have some work to do with that top one. So let's go ahead and graph this one. We're missing an x. So there is no slope on here. That means it's going to be a flat line like this. But let's talk about where is y equal to negative 7. So we're on the y-axis, 1, 2, 3, 4, 5, 6, 7. There, y is equal to negative 7. And then we are going to see that right here y is negative 7, right here y is negative 7, right here y is negative 7. All along this line, the y values are negative 7. Second line. First step, move the x to the other side, just like last semester. Divide everything by 3. And now we are ready to graph. The y value is negative 5 is here. Then from there, down 1 over 3. Down 1 over 3. Ooh. Looks like we're going to have just one solution. These are intersecting lines. Here's our solution. That is the point 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 down. Okay. Looks like I have time on my recording to do one more. So I want to do one of the more difficult ones with you. Let's do number 7. Both of these are not in slope-intercept form. So let's get this guy in slope-intercept form. Your first step is always what? Move the x. Divide by the coefficient in front of y. and we're ready to graph. Notice when you divide by negatives, if you have a negative divided by a negative, it's now positive. All right, so this y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. Then we're going to go up 3 over 5. If you need to, you can back it up. So we know that the line's going to be going like this, so you might want to go backwards. When you do that, just make sure you really still have the same slope, up 3 over 5, so you don't change your line or make a curve on accident. Second equation, move the x to the other side. And since y's coefficient is 1, we don't have to divide, it's ready. Y-intercept, negative 6. 1, 2, 3, 4, 5, 6. Slope, down 2 over 1, down 2 over 1. Ooh, it's going to be kind of hard to get all the way back up to here. So you might want to back it up so you can make sure to get the correct point of intersection. So our solution is 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4 up. There we go. Oh, I think I promised you to do number 6 too, so let's go ahead and do number 6. Okay. The first line is ready to roll. Y-intercept of 5. 1, 2, 3, 4, 5. Slope is in front of x. It's the number 1, so rise 1, run 1. Rise 1, run 1 all day long. The second line is not ready to graph. We need to first move the x to the other side. Y does have a coefficient that's not 1. It's the number negative 1. So when you divide everything by negative 1, it changes our signs. Y-intercept, negative 2. Slope, 1 to 1. Okay, so what do you notice about these lines? These are parallel. So they will never touch. So they have no solution. A lot of times in math you'll see like a 0 with a line through it, meaning no solution. Okay, you have your own set of problems listed as homework attached to this assignment. You have today and tomorrow to get this done and turned in. Thank you.